Well, welcome to geometry. What I'm going to try to do throughout the semester, if you're watching this, here's what I'm going to try to do, is not record the lessons during class, but try to make like a 10 to 15 minute note video for each section and post it on Canvas. That way, you don't have to sit through 40 minutes of notes, but just watch real quick video of what the notes were in class. If you need to catch up, if you didn't understand the lesson, or if you missed a day, stuff like that, it'd be a little quicker and easier to watch the videos. So that's what I'm going to try to do. That's going to be my goal. We'll see how that turns out. This whole first unit and first section actually is all about the basics of geometry. You think of geometry and you think about all the shapes that you're going to be working with. And so what we're going to start with are all the definitions that make up all the shapes we're going to be working with in geometry. We're going to start by talking about definitions of all these things in this chart. So to begin, we need to talk about what a definition is. And a definition is a statement. It's a statement that clarifies or explains the meaning of a word or phrase. A lot of things in geometry have to do with definitions, and so, I say, what is a definition, and you think it's common sense, and a lot of you know what a definition is, but I think it's important to put it into words. Okay, so we're going to define some of these things. We did an in-class activity, but we'll just go ahead and define these now. So a point is a basic unit of geometry. It's a basic unit. A couple things. It has no size or direction. You guys know what a point looks like, and when you name a point, you name it by one capital letter. So I can call that point P or point A. You just pick one letter for it. To have a line, you need 2 points to have a line. So it is a straight arrangement of points. It's a straight arrangement of points. And it forever extends in 2 directions. Forever extends in 2 directions. So I'm going to draw an example of a line. And in geometry, symbols are going to be vital. So to have a line, you need arrows on both ends, and you have to have 2 points that make up the line. Obviously, a line has more than 2 points. It has infinitely many, but you need at least 2. So if I pick 2 points here, if I want to name that line, I would put AB, and I put the line symbol above it. Or I could put BA and put the line symbol above it. Right there. Okay. A plane. A plane is also something that extends forever, but it does it in 2 directions. It's a flat surface that extends forever. Think of a wall in your bedroom. And now think of that wall extending forever in both directions. It's hard to imagine, but that's what a plane is. So it looks like this, if we want to put what shape it is. To have a plane, you need 3 points to have a plane. You need 2 for a line. You need 3 for a plane. So if I put 3 points on here, A, B, C, to name it, I would put plane ABC or BCA. The order of your letters doesn't matter in this case. Okay. Collinear. All right, well, if you have a line, you're going to have points on that line. All the points on a line are said to be collinear. So they are points on the same line. Points on the same line are said to be collinear. And so by the same token, if you have coplanar, well, that would be points on the same plane. Points on the same plane. Okay. Well, we talked about a line extending forever in 2 directions. Now you have a line segment. It's different than a line, and you name it differently. It looks different. It consists of 2 endpoints. So a segment has 2 endpoints. And consists of all the points in between. So for example, here's an example of a line segment. I have two endpoints. We'll call them A and B. Notice I don't put arrows on this. It actually ends in both directions. When I name it, so I want you to look right back up here that I'm circling. I name that with a line symbol above it. When I name a segment, I just put a bar above it. I don't put arrows on the end. That's the difference between naming a line and a segment. Okay. Last two definitions, we'll talk about a few examples here. Array. So the way I always think about array is I think of the sun and then a ray extending from the sun, going on forever. So it has an initial point, like the sun would be the initial point, and extends forever from there. And extends forever from there. So for example, here's what an array would look like. So I'll call that initial point A, and it extends towards point B. Well, I said with a line and a segment, it doesn't matter the order of the letters. Same with a plane. With array, the order of your letters when you name it does matter. You have to start with the initial point, A, and then name a point that it's going towards. And when I put the symbol above it, notice I just have one arrow on the end. So it's going from A to B. Opposite rays, last thing, are two rays with the same initial point. Two rays with the same initial point. And they actually have to be going in exact opposite directions. So for example, right here, there's one ray, and the other ray would go in the exact opposite direction. So we can call that initial point A. I have a point over here and a point over here. So I would say that, here's how I would name this. I would say ray AB and ray AC. Notice even though the ray is going from right to left, I still start with A and go towards C. Those are opposite rays. Alright, let's look at some examples here. So we have to name some things. It says, name a line that contains point E over here in this diagram. So here's the diagram we're looking at. It says, name a line that contains point E. So point E is right here. There's multiple ways I can name that line. If you notice it has a Q right here on the end, I could say line Q. Or I could pick 2 points from that line and name it that way. I have point B and point E. So I could say BE and put the line symbol above it. Or I could put EB. You have multiple ways to name things. It's important to know how. 2 says, name a point contained on line N. Well, line N is this one right here. It says, name a point on line N. So you have 2 options, either point A or point B. Number 3 says, what's another name for line P? So I look in line P is right here. So I pick 2 points and put the line symbol above it. Doesn't matter if you say CD or DC. That doesn't matter. But you need to put the line symbol above it with 2 arrows. Name the plane containing lines N and P. Well, those are the red and blue circles. So that's this whole plane right here. So to name a plane, pick 3 points from it. You need 3 points to name a plane. So I could pick C, D, and B if I wanted to. Call it plane C, D, B. To name a plane, you need 3 points from that plane. Okay. Last couple. It says how many planes are shown in the figure. Okay. So now I need to look. Now, obviously I have this top one here. And then there's 4 along the sides. So that's 5. And then I have this bottom plane and the bottom side of the prism. Well, since they're on the same plane, we just call that 1. Like, try to circle these here. This plane here on bottom and this whole thing, since they're all those points are in the same plane, we consider that 1 plane. So I have that 1, the top one is 2, and the 4 around the sides, that's 6 planes total. Number 2 says name 3 collinear points. That means I need to name 3 points on the same line. I need to find a line that has 3 points on it. And really, there's only one option, because there's only one right here. So point S, X, and M. Number 3 says, are points N, R, S, and W coplanar? Well, coplanar means on the same plane. So are N, R, S, and W, N, R, S, and W all on the same plane? Well, W is way up here on the top part. W is on this top plane. Those 3 are on the bottom. So no. Even though 3 of them are, all 4 have to be coplanar. Okay, last one. So now we're going to take these symbols and draw a picture with them. It says draw 4 points, J, K, L, and M, no 3 of which are collinear. So no 3 points can't be on the same line. So we'll have J, K, L, and M. Okay. Now I have to sketch these figures over here. It says ray JK. I know those are kind of hard to see, but you know that. Notice that arrow right here on the right by K. So it's going from J, extending past K. There's a ray. Segment KL. So I'm just going to connect the dots for K and L. Line MN. I know it's a line because there's arrows on both sides. So I extend. There is no point N. We'll change that to MK or ML. I guess it doesn't really matter. It's a bad question because point N isn't even in the picture. So we'll call it line ML. So I go past M and L and put arrows on both sides. Last one, ray MJ. So I start at M and go towards J. Go past it and put an arrow. Again, these are all the basics of geometry. I know it's not exciting stuff, but these are all the things that are going to make up all the figures that we're going to talk about throughout the course. So it's important to understand how to name them and, given a name, how to draw the picture. Your ability to draw pictures in this unit, or actually in the entire course, are going to be pretty important. So there you have it.